Welcome. We are in Unit K, and in this video we're going to go through Lesson 12.5, in which we get to start learning about similar figures. And these similar figures will come back in future units. So this is kind of laying the foundation here for what does it mean if two figures are similar. We've talked about if figures are congruent, and congruent means exactly the same. Same size, same shape. So we're going to talk about how similar figures are different from congruent figures and look at some properties of similar figures. So let's start with what it means to be similar. For two figures to be similar, so we'll say two figures are similar if they are transformations of each other. Now, transformations, we've learned a couple different types of transformations. So we've learned about reflections, rotations, translations, glide reflections, and then also size changes. So I'm going to say isometries, which are transformations that are reflections, rotations, translations, and glide reflections, or size changes as well. Dilations also count as a transformation. So if we took a figure and we transformed it in some way, our image is going to be similar to the pre-image. Another way of thinking about this is that they will be the same shape, not necessarily the same size. Similar figures are the same shape, not necessarily the same size though. And that's because we could change the size and they're still considered similar. We do have a symbol for similar, and that's just the little squiggle. If you remember congruent, we also have the equal piece, but similar is just that little squiggle. So if we see that little squiggle, that means we know that those figures are similar. Now, the similar figures theorem is going to tell us some important characteristics of similar figures. So I'm going to say if two figures are similar, then two things will be true. So if we have similar figures, we know two things are true. One, their angles are congruent. Just because we are changing the size, we are not changing the shape, and angles actually help create the shape. So the angles never change. The angles stay the same. Remember, we talked about how all of these isometries, reflections, rotations, translations, glide reflections, they preserve angle measure as well as size changes. Dilations also preserve angle measure. So the angles stay the same. However, their sides don't necessarily have to stay the same. They could, but if we do a size change, they won't stay the same. So their sides won't necessarily be congruent, but their sides will be what we call proportional. So I'm going to say their sides are proportional, meaning we could set up a proportion and we would get equal rates or ratios of their sides. So we could create ratios of their sides. They would be equal to each other because their sides are proportional. The last thing that we'll define with similar figures is the ratio of similitude. This is a word that maybe you haven't heard before, similitude. So this is talking about the ratio that we use to compare similar figures. So this is going to be a comparison. A ratio is a comparison of two numbers of the figures corresponding lengths. So we can find matching sides and we can set up a ratio, and that would give us the ratio of similitude. And this ratio will be the same for any set of sides within those similar figures. They should all be the same ratio in order to be proportional. So we're just going to take a look at two examples here of some similar figures and how some of these properties come into play. So first, ABCD. I know this is a four-sided figure. This is my symbol for similar. So I know that ABCD is similar to WXYZ. And I know ABCD is the image of WXYZ under a size change with a magnitude of 2, and that's going to be important here to remember the fact that my magnitude is 2. So I'm going to draw a picture to maybe help me, because here we're given an angle and we're given a couple sides and we're asked to find other angles and sides. So I'm going to draw a picture to kind of help me approach this problem. I do know that ABCD is my image. And we did a size change of 2. So since ABCD is the image, I know that this one should be larger than this one. So I'm just going to draw any 4-sided figure. I don't necessarily care what it looks like, but it's a 4-sided figure. And I know that I want them to be similar. So I'm going to draw WXYZ a little bit smaller maybe, and try to make my other one look the same. So we have figure WXYZ, and then I'm going to draw ABCD. And I want to make sure that my vertices match. So we've looked at notation like this before. I want to make sure that A matches with W. So if I put W here, I'm going to put A here so that I know they match. B should match with X. C should match with Y. And D should match with Z. That's really important when we're looking at similar figures. I want to make sure that they match in my picture. I'm going to label what they gave me. So I know angle B is 85 degrees. I know side BC is 12.1, and I know side AD is 4.2. Obviously my picture is not drawn to scale, but we can still find missing lengths anyway. So we're asked to find as many other angles and sides as we can. So I'm going to go ahead and start with angles. We were given angle B. Now we know if two figures are similar, their angles are the same. The angles don't change. So I can find the angle that corresponds with B. That's going to be X. So I know that angle B and angle X should be the same. So I can say the measure of angle X would also have to be 85 degrees since they are equal. That's the only angle we can find because we don't know enough information about this quadrilateral. I only know it's a quadrilateral. If we knew it was a specific type of quadrilateral, we could maybe find other angles, but we can't do that here just because we don't know what type of quadrilateral it is. So let's go ahead and look at side lengths. Now we're given 2 side lengths. So once again, we can find corresponding side lengths with our other figure. For example, I know AD is 4.2, and that side corresponds with this side, WZ. We know the size change that occurred was a magnitude of 2. So I took this number, we multiplied it by 2 to get here. So if we want to go from our image to our pre-image, so if we're going from image to pre-image, we can divide by that magnitude. So I'm going to take this value and I'm going to divide by 2 to find that missing side WZ. So I can take 4.2, I'm going to divide it by that magnitude of 2, that will give me 2.1. And we can do the same thing with BC. I know this side is 12.1, and so to find side XY, since these correspond, again, to go from image to pre-image, we can divide by that magnitude. So I'm going to take, to find XY, 12.1, and divide it by 2. And that should be 6.05. And since those are the sides we started with, that's all that we can find in our pre-image. We can't do anything else to find missing sides here because we don't know any other information. So those are the 3 angles and sides that we can find. Let's take a look at one more example with similar figures. So here, triangle ABC, again, this is my symbol for similar. So I know that these 2 triangles are similar. So they're the same shape, not necessarily the same size. Once again, we are asked to find as many other angle measures and side lengths as possible. Let's go ahead and start with angles. I'm given angle A, and I want to go ahead and find the angle that corresponds with A. Now, when our pictures are rotated like this, that can make it more challenging. So I'm going to use my notation to help me. I know that A is the first letter here, so that should match with R. So I know that angle R should also be 56. And if we look at side lengths, now here I'm given a side in this figure and I'm given two sides here. So it really just depends on if we can match these sides up. In number 2, we're not given a magnitude. So I can't do like I did in number 1 where we use that magnitude to help us find those missing sides. So I'm going to kind of look and see if I can find sides that relate to each other. This side TR, that's my first and third letter, TR, so I know that's going to match with side AC, which is 30. So I know that 22 corresponds with 30. So I'm actually going to set up a proportion maybe to help me find another side in this triangle. So here again, I know that 22 matches with 30. So in my proportion, I'm going to compare 22 with 30. And then this side 20, because again, this is in my big triangle, 30 and 20 are in the same triangle, so they should match up here. I want to find which side here I'd be finding if we are comparing that to 20. So AB I know matches with RS, so I'm going to call this side X, and we can set up this proportion. So I'm comparing 22 with 30 and X with 20. And if we solve this proportion, we can then find that missing side there. So I'm going to go ahead and cross multiply. That's going to give me 30x equals 440. We can divide by 30. And I'm going to say that's about 14.7. So that was my other side SR that I know is 14.7. Since we're not giving any information about any other angles or about this third side, we can't do anything else. So those would be the only angle and side length that we could find for this example. So we can see that we can use magnitude. We can use proportions like we've learned in order to help us find missing sides and angles in similar figures.